The first thing I'd suggested is you label all the pieces of information that are provided in the problem. So if the radius is 8, I'll draw in my radius. Now, I could draw it anywhere, but I'm going to draw it so that it intersects that tangent at the point of tangency. And I'm going to do that because there's another special property that applies there, right? When a radius and a tangent intersect, they intersect at what? 90-degree angle. So that's a right angle. I'm going to do the same thing here, create my right angle. Okay, I'm also going to label my distance between the centers. So if I connect my two centers here, and I know that that's a distance of 22. All right, so here's where you have to start looking at additional properties to figure this out. And this 22, as you can see here, mine's not necessarily drawn to scale, but it's this red internal tangent is not necessarily going to cut this in half. It would only do that if those are in specific conditions. Okay, so those aren't equal to each other necessarily. Okay, but what you should see is you have these two triangles here. They each have a right angle. And then what do you know about these two angles here? They're equal. So we have two pair of triangles with two pair of angles that are equal. So what kind of triangles are we dealing with? Similar triangles, right? So similar triangles have equal corresponding angles that are equal and sides that are what? Proportional. Okay, so what is the ratio of the corresponding parts between these two triangles? 3 to 8. Okay, so this is how you will decide how that 22 is cut off, right? You can either do it in thinking in terms of part to part or part to whole. Again, anytime we're dealing with ratios, you have that choice. Okay? I encourage you to transition into thinking in terms of part to whole. I think it's more efficient if you can do it that way. And if you can't, that's still okay, and I'll talk through both ways. Okay, so let's do the part to part. If you're somebody who thinks part to part, what you would then do is you would say that this portion, this portion of the 22 is 3 times some multiplier. I'll call it m. Okay, whereas this portion of that 22, that distance between the centers, is a ratio of 8. So it's 8 times that common multiplier. So what you could say here is you could say that 8m plus 3m has to equal 22. If 11m is equal to 22, what does m have to be? Divide both sides by 11. You get 2. So you plug that back in. 3 times 2 is 6. 8 times 2 is 16. So now you've found how you split that side of 22. Okay? Then the next step would be to solve for x. Now, before I go through that next step, I'm going to show the method I would encourage you to use, again, just to save some time. And like I said, any standardized test that you take dealing with ratios, you can normally solve those ratio problems using part to whole rather than part to part in a much easier fashion, often with just a mental calculation. Okay, the same is true here. So if you have parts of 3 and parts of 8, how many total or how many whole parts do you have? 11, right? So the smaller one is going to be 3 out of that 11, and the larger one is going to be 8 out of that 11, right? That's your ratios in terms of part to whole. And so if you know that your whole is 22, you just take 22 and you want to see what's the smaller portion of that. 11 goes into 22 too. 2 times 3 is 6. 8, you can either then subtract 6 from 22 to get your remaining piece, or you can do the same ratio. Your whole is 22. We want the larger portion, which is 8/11ths. It's 8 parts out of the whole 11 parts. 11 goes into 22 too. 2 times 8 is 16. So you can get your pieces in that method as well. And I do think this is faster if you can think of it in those terms. All right. Once you have this information, now most of you will head right to Pythagorean theorem, which is fine. Okay, so you might say 3 squared plus b squared is equal to 6 squared, and then you solve for b. Okay, however, I also want you to try to recognize patterns. Okay, so there are specific patterns that exist. Right? If you look at this triangle, you have a leg of 3 and a hypotenuse that's 6. It's double that leg. Do we have any pattern where the hypotenuse of a right triangle is double the length of a leg? It's a 30, 60, 90, right? So this one happens to be a 30, 60, 90. So if this is x, 2x, what's this piece going to be? X root 3. So the leg is 3. So this is going to be 3 root 3. Same in this triangle here. We have 8, double 8, 16. So what's the piece, this other leg, going to be? 8 root 3. And so you add those together to get your whole length. 8 root 3 plus 3 root 3 gives you 11 root 3, okay, for your solution.